Put on the audio now. So I believe if I'm speaking, you can hear me. But usually lower the. Okay, so here is a diagram shown. So what they ask us to do here. So we're asked to. So this is a trapezium, of course, with vertices A, B, C, and D. All the vertices are given except D. All the vertices are labeled except D. Now, we are told that the side AD is parallel to side BC, and the side CD is perpendicular to side BC, right? So what do we learn from our previous discussion? So I'm just going to use, I think I have my GeoGebra here just to show you the condition that is very important. We talk about equation of a straight line. We talk about condition for two lines to be parallel and condition for two lines to be what? Perpendicular. All other things will basically a match from these three things I've mentioned, all the calculations and all that. So I don't want to bore you with too many things. These three things are what you are going to be using to derive other future stuffs. So let's start with the equation of the line. So we know that every straight line is generally given by y is equals to mx, right? Plus c. We are going to use a slider. I believe I taught you about a slider, right? Slider is just a variable. So m is what? Gradient, right? You see, as I'm changing it to see what is going on. C is what? Intercept on the y-axis. Do you see how it's changing? Do you see how it's changing? So if I have two equations, how do I indicate that the two lines are parallel? So let me do another equation. So I did y equals to mx plus c, right? So let me use another one. Y, can I use y? Should I use y? I want to use a different variable so that to create another slider for me. I think I can use y equals to y and x. Then I can change my m and c. So y equals, instead of using m, okay, let me use m1 and m2 to make this more. You can see the goal is to make math live and interesting, in the sense that you actually see that this thing is not hard as you think. So I'm using m1 and I'm going to use c1. Do you grab? Do you understand? So the second equation, I'll use m2x, right? You get me now? No, let me use m this thing so that I can now label it. I think that's what I should do. So I'll also use y equals to mx. Since I have used m1 and c1 there, so I can use mx plus c. So now, what is going on? It's showing me. So I'll just delete and do a new stuff there. So y is equals to mx plus c. So it's actually giving me the same line, but I'll use a different slider now. So this is m2, and this is what? The other one will be c2. Okay. So what happens if the two values of m1 and m2 are the same, isn't it? So what do you observe about the line? There are two lines now. So we want to do a comparison so that we can now state those conditions. That is very important. So now if I change m2 to, let's say, 2, I can even move the slider if I like. So let me move it. What do you observe? Yes, what do you observe? Let's start with changing the gradient now, which is the value of the m. So what is your observation about the two lines? Good. Now, if I make the two m1 to be this m1 and m2 to be the same, What do you observe? See observation. So it means for two lines to be parallel, what must happen? What must be the condition? Their gradient. You know M means gradient or slope. That means their slope must be what? The same. Do you understand? Okay. Why are they not passing through the same intercept? Can you tell us? Why are they not? No. You know what the intercept means, where it's cut the y-axis. Why is the two line not passing through the same intercept? No, x is a variable. X and y are variables. The only thing that we are choosing, because the two intercepts are different, isn't it? The first one, C1, is where? 2. The second one is where? So what happens if I make the intercept to be the same? So let me change C2 to 1. What do you observe? You have to be very observant to know. So it means two lines will be together if one, they are both parallel, means their gradient or slope are the same. Two, they have the same y-intercept. Under that condition, when you have a quadratic two, you know all these equation of straight line, they are representing a linear equation. Am I correct? So when you have two linear equations, where they meet is also the solution. We are doing really, we are relating this to simultaneous equation now. So when you know how to get the slope now. The slope is actually the coefficient of x, while the constant term, the intercept is the constant term. So when the slope, the coefficient of x in both of your simultaneous system of equation, linear equation, is the same, and the constant term is also the same, what happens? There will be no solution because the two lines will be on each other. But when at least only when their intercept, their constant term are different. Okay, sorry, what am I saying? When the slope and the intercept are the same, the slope of the two, that's the coefficient of x for the two system of equation are the same. The constant term is also the same. The two lines will be together. So we can't say there's no solution. There will be infinite solution. Infinite solution because they meet, they are just together. Now, when the slopes are the same, you know what I mean by the slope now, the coefficient of x. By now you should know what it means. But the intercepts are different. So now we are using C1 to be 2. What happens? That would be a parallel line, right? Those two lines will never meet because when they meet, that's when there will be a solution, isn't it? So now, what happens if the intercepts are different and the slope are different? So I've changed the slope now. You can see now, M2 is now 0.3. What happens? There is a solution, isn't it? Look at where the solution is. This is the solution. That's the x-intercept, negative 1 point, the number is very big, and the y is 0.57. So it means that for there to be a solution to any system of linear equation, because the equation of the straight line is actually a linear equation. You can always rearrange it in form of y equals to mx plus a, which shows you a straight line. So the moment you compare the coefficient of the two linear equations and they are not the same, it means they will intersect and there will be one solution. So we've talked about condition for two lines to be parallel. Now, what is the condition for the two lines to be perpendicular? Now I want you to take, so I'm going to adjust, I'll keep adjusting the line. If I actually want to make this red line perpendicular, see what I'm doing. I think I have to move it like this, move it like this. I'm moving. Unfortunately, I cannot move. Okay, I've moved. I think it's somehow perpendicular, right? This. So this one, I'm just playing with it now. So we can say it's perpendicular. Why will we say it's perpendicular? Let's measure the angle. So we have some tools to measure angle, right? Once we measure the angle and the angle tells us 90 degrees, that means they are both perpendicular. So I'll go to my tools and I'll go to what? Angle. You see that? If I click on it to give me a suggestion, what's coming out from there? Select 3 points or 2 lines, right? Select 3 points or 2 lines. So let me go with the lines, 2 lines. So I can select this line and this other line. What do you see? Though it gives me the angle in the other part, but I can use what they call it now. Sum of angle on a straight line, isn't it? You get it now? Are you seeing the bit? Are you seeing this? So the two lines are what? They are perpendicular to each other. Now, I was adjusting the gradient, right? So what can you say about the two gradients, M1 and M2? So I want you to deduce something. Can you take note of the gradient? Then we'll do another one. We'll make sure that they are perpendicular. So maybe we'll do two examples. Then from the two examples, you should try and make your conclusion that, okay, when they are perpendicular, this is the condition. What we are dealing with now is condition for two lines to be parallel or two lines to be perpendicular. We've learned that for two lines to be parallel, the two gradients or slope must be what? The same, right? Now, we want to learn about the condition for two lines to be perpendicular. Okay, so you just observe M1 is 1, M2 is what? Oh, look at the values, -1, okay? So let's make some other change. So I'm changing M1 to be 0.4. Hope you see that. You can see the angle is not 90 now. Please focus, leave your phone for now. Now, I want to make it 90 degrees. Almost 90, right? Very close to 90. Fortunately, I have to move it a bit. Wow, it's 90 now. Okay, take note of the two gradients. What is the gradient of M2? You can convert it to fraction. Good. The first one, 1, -1. This example now, 0.4, -2.5. And 0.4 is the same thing as 4/10, which is 2/5, right? So that's 2/5. -2.5 is the same thing as what? -5/2. Can you make a deduction from there about the condition? I don't want to tell you, I want you to figure it out. Yes, like if you turn it upside down, right? Then you now put minus. Do you get it? Remember for the other one, it was 1. So if we turn 1 upside, of course, reciprocal of 1 is 1. So if you turn 1 upside down, it's still 1, but you put minus there. You get the gradient for it to be 1. But this one now, 2/5. If you turn 2/5 upside down, that will be 5/2, but you have to put minus there. Let's take one more example. I don't know if you are getting it clearly. This is helping you to demystify maths. All this thing I will have used writing. Just this illustration we have done to stick to you for life. So now let's adjust the variables to 0.5. You can see it's not yet perpendicular, so let's adjust this other one. So before we do it, what do you think M2 will do? I've not yet done it now, but based on what we have said, we want to see if our hypothesis is actually going to be correct. So what do you think M2 should be? I've not yet adjusted it to be exactly 90. So you use this our hypothesis now to make your conclusion. So the first one, 0.5, which is 1/2 of 5/10 is 1/2. So what do you think the second one should be? So that I will not need to adjust, I'll just type it in and see if it becomes 90. We have, that's minus 10 over 5, which is empty as minus 2, right? So instead of me adjusting, should I just type minus 2 and see if that will change to 90? If it does, that means our hypothesis is correct, isn't it? So with that, we know that that is the condition. So anytime you ask you to two lines are perpendicular, you know that they are what? Their gradient is if you know the gradient of one, just take the reciprocal and negate it. So now let's go to the question. Take this one. So now, and you know how to find gradient too. Of course, you already know how to find gradient now. Change your rise over rho. You know how to find that. Good. So if they say the line, what do you call it? AB. Okay. They said AD is parallel to BC. That means the slope of those two lines must be the same. Let's find this. Can we find the slope of one of them? We should be able to find the slope of BC, right? Because the coordinates are given, isn't it? So let's find the slope of BC. So what's the slope of BC? So I'll just type something here. The slope of BC, of course, you know what slope is now, y2 minus y1 over what? So let's define slope. Slope of a line is given by what? Y2 minus what? Y1, right? Over what? S2 minus x1, where y2, y1 are the corresponding y coordinates. So now, what is the slope of BC? So you tell me now. So, you know y coordinate is always the second coordinate. 7, 7. So that will be 7, right? Okay. So whichever way you are going, if you take that one to be y2, then that other one has to be a y1. So that will be 7 minus 2. Am I correct? BC now. The y coordinate of B is 7. The y coordinate of C is 2. So if we are starting from BC, let's take B to be our starting point as y2, then it means C has to be y1. So that will be 7 minus 2. Am I correct? So let me put that in brackets. 7 minus 2 divided by what? S2 from B. That's 7 minus S1 negative 3. That is 7 minus 3, which is 7 plus what? 3. So when we do the calculation, 7 minus 2 is 5 over 7 plus 3 is what? 10. And what is 5 over 10? That's 1 over 2. Okay. So now we know the slope of BC. We are given only one coordinate for A. We're not given for D. But we know that for the condition that both lines are parallel means that the gradient of or the slope of AD has to also be what? 1 over 2. Isn't it? Because they are parallel. We've done the practical and the experiment. So that means we can now say the slope of AD, depending on where we are starting, so we now know that at point D, we have two variable points that we need to look for. So let's put those two variables. Hope you are getting this thing. So let's call the variables x and y, right? We don't know that we are looking for them. X, comma what? Y. Are you with me? Good. So now, so now, depending on where we are starting from, so we are going like this from A to what? D. So our y2 is 4, right? Then our y1 is y. We don't know what it is. So that will be 4 minus y. So which means 4 minus y, are you there? Divided by 11 minus x. 11 minus x. What do you ask us to find? Area of trapezium. So we might need to find out the coordinate. 11 minus x, isn't it? Everything has to be same as what? 1 over 2. True or false? Yes, because since ABC is parallel to what? To AD, right? So we can now actually rearrange the equation so that we can form an equation. So when we form the equation, we know the equation of that line that is actually passing through that point, and that might help us. But what we are interested in is to find the area of trapezium ABCD. So if we are finding the area of trapezium, you know that area of trapezium is distance between here and here. Distance between here and here. Then that's half AB times AB plus like this side, half length of this side plus length of the other side times the height. So we need that information. So just let's get the coordinate because we'll use it to calculate the distance. You know there's a distance formula now of 2 coordinates. So I will show you in the GeoGebra and then we'll show how to calculate. So since BC is parallel to AD, let's see that. So let's get the equation of that line. So if we rearrange 4 minus y, we're having a class. Yeah, our class usually do virtual, so it's virtual. Yeah, 10. Yeah. English. Yes, yes, yeah, 10. English. So now we need to. Sure. So I believe you're actually understanding what we're doing, right? So now we need to find the equation of that. So from a 4 minus y over 11 minus x equals 1 over 2. So when we cross multiply, we have 2 times. Just look at it. 4 minus y. Am I correct? Because 2 multiply that side. You know it's a fraction. Is equals to 1 times 11 minus x, which is 11 minus x. So we can open the bracket. 2 times 4, 8 minus 2 times y, that will be 2y equals to 11 minus x. So we can rearrange it in form of y equals mx plus c. So when we do that, we can take 8 to the other side, so that only y will be there. So that will be negative, or let's take y to the other side so that all the negative will be away, and bring all the 11 minus x to the other side. You get the trick. So now I have 8. So when 11 goes to the other side, then my negative 11 plus x, am I correct, equals to 2y. Just a trick anyway. 8 minus 11, that's minus 3 plus x equals to 2y. Am I correct? Which can still be written as 2y is equals to x minus 3. Because negative 3 plus x is the same thing as x minus 3. You understand? Negative 3 minus 3 plus x is the same thing as x minus 3. Yeah, but since we want to make y subject to a formula, we have to divide through by 2. So when you divide through by 2, that will be good. Sorry, and this thing is freezing. One over, yeah, no, it's not minus 1/5. Y will be 0.5 now, 1 over 2x plus minus 1.5. Yes, minus 1.5 will be the constant term c, while your slope will be what? 1 over 2. You get it now? So y will now become equals to, let's say 0.5, let me use decimal, x, right? Minus 1.5. So which means if you plot the graph, the intercept on the y-axis should be you should cut the 1.5 like on your y-axis, then the slope should be 0.5. How would this help us out? Well, we need to find, because if you want to find remember, if you want to find the area of a trapezium, first find half the length of this side plus the length of the other side, and then you now multiply by height. So we don't even know the height now, and we know the height is actually a perpendicular line. So let me just see. It's more like complex, but then if you understand these basic things where I've just explained to you now, you can always break it down, and it's become easier for you to understand. Okay, so now we can find the distance between B and C, right? Using the distance formula. So let me quickly introduce you to that distance formula. So, okay. So I'm thinking of what we're going to do now. So we need to find the height of the what do you call it, trapezium. Okay, because we can't actually know exactly what x and y is even with this equation. The only way we can know is if we're given where it passes through, where AD passes through. Already we have an equation for that line. You know, we did an equation like that whereby we have the equation of the line. We're now looking for the constant. We now have to use where the line passes through to find the constant. So I think we're giving more information about where that AD passes through, then we know that whichever point that it passes through must also satisfy that equation, because that's the reason why they call it equation of a straight line. It means any x and y you pick, we always obey that equation. Does it make sense? But unfortunately now, we're not giving, I think that's what makes it a bit harder. We're not giving, what do you call it now? where it passes, but we're given an additional information, which is what we are going to use to solve this question. So the additional information says that AD is parallel and the line CD is perpendicular to BC. So we now have to use that condition. So now the line AD is given by y equals to 0.5x minus 1.5. So what do you think line CD would be since they are perpendicular? So we now have to use the condition. The line CD, because CD is parallel to what? BC, right? They said the line. So what? Sorry, AD is parallel to BC. So the equation of, so y equals to 0.5x minus 1.5 is the equation of for line AD. So it's also like the equation for line BC, just that their, what they call it, intercept is different. Okay, I think we need to find the equation for line BC. It will almost look like that for line AD too, because they will have the same gradient since they are parallel. The only thing that their intercept will be different because they are not cutting the same point. So I think let's find the equation for line ABC. So we say which is for AD. So that one is for AD. For BC, we have, so it's still going to be y is equals to, well, both of them, they are parallel, 0.5 from the condition that they are parallel, so they are gradient system, x plus a constant we don't know. You get it? So we are now to find what C is. So here is, we can find it because we know where the line is passing through 2 points. So we can use one of the points. So you can see that basic thing you need to know is just understand that equation of a line and usually use it to derive further thing. So one of the points BC pass through is 7,7. So we now say since BC passes through 7,7, so that means where x is 7, y is 7, we'll now use it. Since BC passes through 7,7, meaning that x equals to 7 and corresponding value of y equals to 7 must satisfy y equals to 0.5x plus c, because that's the equation of the line. Must satisfy so I'll just copy and paste this. So it must satisfy this equation. So let's substitute it into the equation because that's the point on that line. So which means that we have 7 is equals to 0.5 times 7. 0.5 times 7 is going to give you 3.5, am I correct? 3.5 plus c. Do you get it? So c now becomes 7 minus 3.5, which is 3.5. So we've gotten the equation of that line. So the equation of, so that means y equals to, let me go down a bit. So y is equals to 0.5x plus 3.5. So you can see that those is for BC. I hope you get it. So those two lines are parallel. That's why their slope gradient is the same, but their intercepts are different because one is, of course, it makes sense because 3.5 is the higher intercept. That's why you see that BC is up while AD is down. So now we are told that, and the side CD is perpendicular to BC. So we use that similar condition that we use for parallel line, that we use to get the equation for line AD. We we'll now use it to get equation for line CD2. So to do that, since CD, I believe this is logically making sense to you. Since CD is perpendicular now, not parallel to BC, right? That means the gradient of BC is 1 over 2. That means the gradient of CD will now be, for his own line, will now be 1 over 2, that's turn it upside down, 2 over 1 minus, that will be negative 2. So that means y will be negative 2x, right, plus c. We don't know what c is. C is the intercept on the y-axis, which of course the weight is going to be a negative intercept. Although it doesn't meet yet, but the way that line is. I told you the difference between line and line segment. Those are line segments, but line is infinite, it goes. So since it passes through, so I'll just copy this statement. So you can see that whenever it passes through a point, it enables us to find either the coordinate or constant or whatever. Please take note. So let me go, which is for CD, right? Since CD, this one passes through 1 point. 1 point is enough for us. Since CD passes through negative 3, comma what? 2. You see it? So it means that point must lie on that. Since that point lies on that line, it must satisfy that equation. So which means the y will be what? 2, and x will be what? Corresponding value of x will be what? Negative 3. So since the point on that line, it must satisfy that equation. So our equation becomes, what is y? 2 is equals to negative 2 times negative 3 is now what? 6 plus c. So c becomes what? 2 minus 6. That's negative what? 4. Which makes sense with that, because the intercept, if you even look the way they draw it, is going like this. So the y-intercept, there are two y-intercepts, either the positive y-intercept or the negative y. So the way it's even going is going to cut below. So this actually makes sense to us. So we've gotten the equation of those lines, but we need to find the value of x and y. You get it? Because we need that coordinate, those points. And remember, the way we find coordinate of points, if two lines are coming like this, is to show that, of course, those two lines will intersect because their gradients are different, isn't it? So where they meet is how we are going to find the coordinate. So now we have two lines, CD. So let's look at the equation of line CD. So equation of line CD is y is equals to, because those are the two lines, CD and AD, they meet. So y equals to negative 2x, we'll find the constant now, minus 4. Okay? Which is for CD. And for AD, we've gotten AD before, so I'll just copy what we did here. And then we'll equate them together. See that there's nothing difficult in this thing. It's complicated, but each steps are simple actually. So since both lines meet, right? Since both lines meet at x, y, right? Which we don't know yet, so we want to look for it. So I'm going to equate them together. So equating them, that will be negative 2x, negative 4 is equals to 0.5x. Are you with me? Negative 1.5. So we can solve for x. Once we get x, we can get y. So now I can take 0.5 to the other side. So I think 0.5 to the other side, I can bring minus 4 to the other side. So that will be negative 2x, negative, because 0.5 is not positive. So negative 0.5x, are you there? Equals to negative 1.5, right? Plus 4. From negative 4 will become positive 4. So what is negative 2s, negative 0.5? That will be negative 2.5. So negative 2.5x is equals to negative 1.5 plus 4 is same thing as 4 minus 1.5. That's 3.5 into 3.5. So solving for x now becomes 3.5 divided by 2.5. That would be like 35 divided by 25. So let's use our calculator for that. Let's leave it in fraction or decimal calculator. Hope you're understanding this one. Good. So what? So I'm trying to calculate. You can also use your calculator. 3.5 divided by 2.5 or 35 divided by 25. If you remove the decimal, is what? Yeah, 1.4. So that's 1.4. That will be negative 1.4 because there's a negative there. Okay, so we've gotten the coordinates for x. To get for y, we just substitute x equals to negative 1.4 in any of those two equations because both of them meet. So substituting into, so let's just do it. So that will be y is equals to, I think the first equation will be easier for us because that's minus 2s minus 4. So let's use that first equation. So that will be minus 2 times minus 1.4. That should be 2.8 because minus will become minus. So that minus will become plus. So 2.8 minus 4. So what's 2.8 minus 4? You can use a calculator. Yeah, 2.8 minus 4. 2.8 minus 4. Minus. Okay, that's negative 1.2, right? So negative 1.2. So which means this coordinate here is, our coordinate is negative 1.4, which is actually true because even the way the thing where it's positioned, you can see that it's away from this thing, and negative 1.2 because it's actually below the y-axis. So now we can find the distance BC and AD. There's a popular formula for distance. So the formula is square root of, or you can say d square, is actually from Pythagoras theorem. D square equals to the square of x2 minus x1 plus the square of y2 minus y1. Then you take the square root. So kind of complicated. So let's do that. So to find the length of BC, let's start with BC because that one is given to us. So this is coordinates of D. So the length of BC will be given as, so I'll just do it straight. The length of BC so becomes BC square. BC square, or we'll take the square root, just take the square root directly. So square root of, I don't have that function. So we now subtract. So if you are going from B to C, you must maintain that order. So from B to C, 7, that's for x, right? Minus 3, that will be 10. So 10 squared is what? 100. You get it? plus BC now 7, that's the y coordinate now, minus 2, which is 5. 5 squared is what? 25. So that's the square root of 125. Use your calculator, please. Square root of 125, what do you have? That's the length for this. What do you get? 125, yes. That's the length of this. 1.5. 125, square root of 125, 125. 11.18. 180. So two decimal places will be 11.18, right? Okay, good. So we've gotten that. So now the length of, let me check calculator, length of the other side of the trapezium, ED. So that's AD equals to square root of, so A is 11 minus D, the x there is negative 1.5 and negative 1.4. So 11 minus 1.4 will be 12.4, isn't it? So 12.4 squared, please calculator. So what's 12.4 squared? 12.4, let me put your calculator. That's 153.76, isn't it? 153.76 plus, from A, the y coordinate 4 minus the other D, negative 1.2. That will be 4 plus 1.2, that's 5.2, right? Square of 5.2, please calculator. Square of 5.2, yeah, 5.2 square. That would be 27.04. Am I correct? 5.2 square. Square, not square root 2. Okay, so add them together. 153.76 plus 27.04. What would that give you? Plus 153.76 plus 153.76. So that will give you 180.8. Okay, so now find the square root. 180.8. What is the square root of 180.8? Square root of, and this one doesn't have square root. Okay, it has 13.45. Do you confirm that? So 13.45. So we're almost done. Area of trapezium, area of ABCD is equals to, it's a complex problem anyway, but it's doable. Half AB, we got the AD right, 13.45 times BC, 11.18, right? Times height. If you were yet, that's just what is left. But let's do it. So 13.45 plus 11.8 plus 11.8. 11.8. 25.25 to 2 decimal place. Confirm. 25.25. So 1 over 2 into 25.25, right? Am I correct? Times height. This will be the only question we'll do for today. So how do we get the height? The height is actually, so let's go back to the diagram. Hope you are paying attention. So the height is a perpendicular line. So let me just see if I can insert something to make it clear. I want to draw something here. I don't know if I can use, this thing actually doesn't have a geometric, but I'll just use, so the height is this line. Look at it. Just draw a straight line. You get it? You can either use here. So this black line from B to wherever this it meets it is the height. Or you can do it at C and D, this other end. The height doesn't change. But I would prefer to use B and C because those ones the coordinates are given. So how do we get the height? Hmm. If we can get where this point is, let me change the color. Here, this place. We already know from here to here. We can get this point. So let's call it S, comma Y. I'm using a red color now. But we know that this line is a perpendicular line. That line is perpendicular to AD, am I correct? Because this is the way it's going. B, C, and AD, they are parallel. But that line is perpendicular to it passes through B, 7, 7. Then it meets. So we have to use something like intersection. So that means we need to find the equation of that line. Get it? So that when we find that equation, we already know the equation of either AD. We know the equation of AD. So if we can get the equation of the line that is perpendicular to it, passing through that one point B, that will help out. This question is it's matured question, but I believe we are getting the basic question. So now let's find the equation of the line that is perpendicular to AD. So first we need to go and look at the equation of line AD. Where is it again? This one, right? So I'll just copy. Okay, so I've copied it. So that's for AD, right? So the perpendicular line that passes through the perpendicular line, so let me just start the perpendicular, let's say the perpendicular line, yeah, perpendicular line to AD passing through B will be given by y is equals to, so gradient of AD is 1/2. So that means the gradient of that one has to be negative 2x. But hold on, do we even need it? Since now, I think we are going to be doing two work. Because I remember we find the perpendicular line, right? Let's go back to that place. Since line CD is perpendicular to BC, so this equation that we got for CD, where is it again? I'm looking for it. So I'll just color it red. Will now be the height. Do you know why? Because AD and BC, they are already parallel to each other. So if this side is perpendicular to this line, automatically it will be perpendicular to that side too. So it can be, it is a height. I'm calling it red. No. Control Z. So I'm making this one to be get why I'm changing it now to show that that thing is important for us to use. So, what we now need to find is, so that means CD is a height. I don't know if I'm making sense. So we don't need to go and be finding equation, because that line you want to find now is also like this to CD. You get it now? So what it's saying is that, let me pick my pen. So all these things are just, what it's saying is that, let me bring this one. So what it's saying is that this place is also going to be 90. Okay? So I can now claim this line. This line is not necessary. You grab. So that's the point. So the distance CD is what I need to find. And I already know my x and y. So I don't need to get this other one based on the properties. So I don't need that part. So all I need is what? To find a line CD. So let's go and find line CD. Once we find the that distance, we're done. So that basically is all. So I will just remove this other information here. So I can add it. I can remove all of this. I'll now say since CD is perpendicular to what? To AD, and AD is parallel to what? To BC, right? It's therefore it must be the height. It must be the what? The height of the trapezium. A, B, C, D. So now let's find the length of CD. So the length of CD equals to, so take square roots, SQRT. You know what that means. So let's go up. So we know what, so let me just, C is 3, 2. So let me just bring it down here so that you see. C is what? Is it 3, 2 or negative 3, 2? And D is what? Negative, because we need our coordinates, right? Negative 1.4, comma, negative 1.2. Do you see that? Let me go up again. Yeah, CD is negative 3, 2. So we'll now use it to find the distance that we get the height. So we are starting from C to D. Just make sure that whichever order you are going, you maintain that order. So now, negative 3, that's for our x2, negative minus negative 1.4. So that will be negative 3 plus 1.4. So what would that be? Please use your calculator. Negative 3 plus 1.4. Negative 3 plus 1.4. When you're done, you get what? Minus 1.6, right? Square it. 2.56. Is that what you get to? Confirm. Minus 1.6 square. No. Square, not square root. Square. So am I doing the wrong thing? 16 times 16 is 256 now. So you didn't do the correct thing. Minus 1.6 is 1.6 now. Negative minus 3 plus 1.4. You're not concentrating. Okay. So that's 2.56. Okay, good. So that will be 2.56 plus, now we have 2 minus 1.2, that will be 2 plus 1.2, which will be 3.2, right? So square of 3.2, square or not square, 3.2 whole square will be 10.24. Please confirm. 10.24, right? Is that confirmed? So now you find the square root of, add 2.56 plus 10.24 plus 2.56. We get 12.8, right? Okay, good. So find the square root of 12.8. That will be your answer for your height. So the square root of 12.8, yeah, square root. At the end of the day, the distance is this square, so you have to take the square root of the side. 3.58. I don't know if that's what you got to. 3.58. So which is the height? Square root of 10 points. Is it 10.8? Let me check. 12.8. Not 12.8. Let's say 10.8. Sorry. Okay, good. So now we now have the height. So let's just use it in the area of. So the area of. So we are done with this problem. The area of ABCD or trapezoid ABCD becomes 1/2, that's 0.5, am I correct? Times 25.25, we've already gotten that, times our height 3.58. So do all the multiplication. So times 25.2 times 25 times 25.25, please. Sorry, 25.25, then times 0.5. Yeah, that should be 45.19. 45.17. I'm saying 169 here. Okay, I didn't approximate. Okay, yours was approximated. So you got 45 point what? 19. Come again. 1975. So let's say 198. So that's the area of that. It's a very difficult question, but again, we get the basic stuff. So, any question? Are you sure you get all the concept? Right. So I think we'll call it a day here. So we'll continue class next week. So you can always use this what do you call it? The link to connect. Just chat me up on WhatsApp so that we'll start, and even if you are not here physically, you can have advantage of the lesson. Okay, so I'll stop the streaming now.